Friends, today we are going to see some more interesting and important questions from Narendra, Avasthi sir's physical chemistry, mole concept. Come on, let us discuss few more questions from this session. Here the first question. 3 solution of X, Y and Z of HCl are mixed to produce 100 ml of 0.1 m solution. The molarities of X, Y and Z are 0.07 m, 0.12 m and 0.15 m respectively. What respective volumes of XYZ should be mixed? So here in this question, they have given the molarities. We have to find out the volume of XYZ. And first they mentioned that 3 solution of XYZ of HCl are mixed to produce, that means X plus Y plus Z. That is a volume of Vx, Vy, Vz to produce 100 ml of 0.1 m solution. Now we have to identify the respective volumes. So let us write the data to analyze this question. So the molarities of XYZ, let us write that. So molarity of X, Y and Z. So molarity of XYZ, X it is 0.07 m and Y it is 0.12 m, 12 m and Z at a 0.15 m respectively. Right now volume, this is, we can make it out because we have to identify volume, right? So we can mention Vx, Vy and Vz. So this is combined, that means mixed together and produce 100 ml of 0.1 m. So let us add this. So you will get 100 ml. So now we have to identify the volume of the solution. Before finding out the volume of respective solution, we have to find that moles of this point. So moles, usually what we will identify, molarity is equal to, see this is molarity equal to N by V. So that means moles by volume in liter. Now volume we have to identify. Volume we have to identify for that. This is actually moles by molarity. Okay, now this is actually mixed solution. So mixed solution means here we can use another one more formula because X, Y, Z we can identify M1, M2, M3 of molarities of X, Y, Z. So that means here M1 V1 plus M2 V2 plus M3 V3 equal to M total into V total. Right, so the M1 V1 also M1 into V1 plus M2 into V2 plus M3 into V3. So you will get M total and V total. This is actually a formula. Now this is actually what it is. Combined together, the mix of X, Y, Z combined together, you will get 100 ml. Right, now millimoles, 100 ml. No, millimoles we have to identify. So how to find out that millimoles? See, total millimoles equal to 100 ml. That means volume into molarity. So volume it is 100 ml into molarity it is 0.1 mixed together. Now you see, mixed to produce, right? In the question it has mentioned mixed to produce 100 ml, right? I hope you got an idea. So what is the answer? You will be getting 10 millimole of HCl. Millimole of HCl, right? So 10 millimoles of HCl you are getting. Right, now molarity equation, how to mention? So molarity equation. So how to identify that molarity equation? M1 V1 M2 V2, right? So that means here M1 what it is? 0.07 M1 into V1 what it is? Vx, right? And the same way M2 0.12 Vy. I hope you got that idea. Now I think you are able to write the answer for this. Right now 0.15 Vz equal to, combined together volume into molarity equal to what it is? Millimole. So this is, you are getting how much? 10 millimole. Right. Okay. Now this is a molarity equation. Now we have to identify the volume equation. What is it? Volume equation? Vx, Vy, Vz. Right. Here you see Vx, Vy, Vz equal to 100 ml. Okay. I just rearrange this equation for you to understand. So here volume equation. Here Vx, we just bring it out. Vx equal to 100 minus Vy minus Vz. I hope you got that both the equation. So this is a molarity equation. M1 V1, M2 V2, M3 V3 equal to M total V total. That is a moles. So that we are bringing. And the same way here volume equation. Here Vx, Vy, Vz combined together 100 ml. So that we are bringing Vx equal to 100 minus Vy minus Vz. Okay, can we apply this value, Vx value, to this point, right? Vx is here. No, can we apply in this point? Okay, so that means here 0.07 into 100 minus Vy minus Vz plus here what it is 0.12 Vy plus 0.15 Vz equal to what it is 10 millimole, right? Okay, now let us calculate this point. 0.07 into 100 minus Vy minus Vz. So you will get what it is 7 minus 0.07 Vy minus 0.07 Vz plus the same 0.12 Vy plus 0.15 Vz, right, equal to 10 millimole. Right, now here component 7 and 10 is there, no? So we bring it this side. So here 10 minus 7, this 7, no? Just bring it this side. So here you will get 3, right? And the same way here, one by one we will go. So here what it is, Vy, it is there, here also Vy. So that means here 0.12 Vy minus 0.07 Vy. So how much you will get both? So you will get what it is, 0.05, right? So 0.05 Vy. And the same way here, Vz also it is available here and here. So here what it is, 0.15 Vz minus 0.07 Vz equal to how much you will get 0.08 Vz. Okay, can we apply all the values here? So that means here 0.05 Vy plus 0.08 Vz equal to 3. I hope you got that idea. V3. Right, so that means this is the fundamental idea to apply the values. Now Vy and Vz value we got it. So Vy 0.05 Vy plus 0.08 Vz equal to 3. Now come on, let us apply this value to that volumes of the given solution. What is it, volumes of the given solution? Option A, it is 50 ml, 25 ml, 25 ml. Now how to apply that same idea? Yes, I would like to give that idea how to apply. Yes, now this is 0.0 Vy and Vz, it is Vy and Vz. Actually here Vy equal to 25 ml, right? Option A I just mentioned, and Vz equal to, it is 25 ml. Vx, whether it is 50 or not, we have to check it. So how to check it? So here what it is, how to apply the value here? So here Vy 0.05 into Vy, it is 25 ml plus 0.08 Vz value, what it is, 25 ml, right? Can you calculate this? You will get how much? You will get 1.25 plus here how much you will get? 2 you will get. So 1.25 plus 2 you will get 3.25. So here actually what is the answer you are getting? 0.025 Vy and Vz combined together you are getting 3, but here 3.25, which is above that point. So that means this option will not be applicable. Right, it's the same way. So that means suppose if you apply this value, so Vx, Vy, X, Y and Z, I think you got an idea how to identify. So X, suppose 100 minus 25 minus 25, so how much you will be getting? 50x, right? So 50x, so 50, 25, 25, which is not possible because you are getting above that value. Right, now as we observe here, let us check the option here 20, 60, 20, 40, 30, 30 and 55, 20, 25. Let us check option D because I just mentioned here how to apply for each. So Vy and Vz you just take it, and Vx we have to identify. For that Vy, that is Vy, this you have to identify. 0.05 into Vy value, 0.08 into Vz value. You have to get 3 when you add these two values. Now option D, let us check how to bring the answer. The same way here 0.05 Vy plus 0.08 VZ equal to 3. Now here option D, what it is? Option D, what is the first one? Here V X, V Y and V Z. So here what they have given 55, 55, 20, 25. So let us check whether we are getting 3 or not this answer. Now that means here Vy. Here Vy, what is the value? 0.05 into 20 plus 0.08 into 25. Right. So how much you will be getting here when you add these two? So here you will get 1 and here you will get 2. So both combined together you are getting 3. Right. So when you add these you are getting 100. That is not a matter. But this you have to bring 3. That is only the correct option. Right. Millimoles, if it is correct only, you can apply that answer. Okay. So that means Vx equal to. Now let us check. So that means this answer it is 3. Right. Now let us check. Vx equal to 100 minus, here what it is, 20 minus 25, right? So that means how much you will be getting? 55 ml. So when you do this calculation, you are getting 55. So that means here Vx, Vy, Vz, here 55, 20, 25 is the correct option. If you want, you can apply other values also, option B, option C, you just check it. I hope you got that idea. This is a one way to solve this kind of questions. I hope you understand this question. Now, which is the correct option? Option D is the correct option. This is little bit lengthier question only. I just increased the speed of video because it is taking longer time. Nearly more than 1 hour it is taking. Really, we could not concentrate for. That is the reason I just increased the speed of video. I hope you got an idea. See, yes, come on. Which is the correct option? Option D is the correct option. This is the correct option. Come on, let us go to the next question. The next question, a bottle of an aqueous H2O2 solution is labeled as 28.375 V. H2O2, hydrogen peroxide, and the density of the solution in gram per ml is 1.25. Choose the correct option. Right now here, density of the solution they have given. So density equal to mass by volume. So this question, it is related to the concept of molality. Molality, it is actually molality. What do you mean by molality? Moles of solute per kilogram of the solvent. Moles of solute per kilogram of the solvent. Right, mass of the solvent in kg. That is the way also we can mention. Right now, here mass of the solvent. Why I'm giving this ideas? So to analyze the question. Now here, mass of the solvent, how to identify? Mass of the solvent. Mass of the solvent equal to mass of the solution. Mass of the solution minus mass of the solute. Mass of the solute. I hope you got that idea how to analyze this question. These are the steps to note down. This is the basic idea, concept for this question. Right now, density of the solution. What is the density of the solution? In this question, what they have given? Density of the solution. Density of the solution equal to 1.25 gram per ml. Right. So here we just convert mass of the solution. Mass of the solution, we should get that. This is density of the solution. Density D equal to what it is? Mass by volume. So mass of this solution. So now we are going to take the mass of the solution. Here density of the solution. Now we have to find out the mass of the solution. Mass of the solution, M, we will bring it here. So automatically what it is? D into V. So density into volume of the solution. Volume of the solution, it is nothing, 1000 ml, right? 1 liter. Mass of the solution. Mass of the solution, what it is? Here, density into volume, right? M equal to D into V. So here M equal to D into V. So D, it is what it is? 1.25 gram per ml into volume of the solution, 1000 ml. So this ml and ml will be cancelled. Right now here, what is the answer you will be getting? 1250 gram. Okay, so mass of the solution, it is, we got it. That is what I just mentioned here. mass of the solvent, if we want to find out mass of the solution minus mass of the solute. So mass of the solution, we got it. Now mass of the solute, we have to identify for that. Right now here, mass of the solute we have to identify. That means given mass we have to identify. I hope you got that idea. Yes. Now here equation H2O2, it gives H2O plus O2. So here what it is? Is it balanced? Yes, it's balanced. Right now here 2 moles of hydrogen peroxide, this 2 moles of hydrogen peroxide can produce 2 moles of water. 2 moles of water and 1 mole of oxygen, right? So in that way here, according to this balanced equation, now actually this is made up of what it is? STP. So here volume of oxygen we have to identify. So volume of oxygen equal to, we have to use standard temperature pressure for that. Here mass, actually we have to identify that mass divided by 2 moles of hydrogen peroxide can produce 1 mole of oxygen. So that is 2 into molar volume, that is 22.4 liter per mole. Right. Okay. So this is gaseous temperature and pressure, standard temperature and pressure. No. So we are using that molar volume. Right now, when you calculate this, you will get what it is, 11.2 into mass. That is actually, now we have to identify that moles, number of moles. So how to identify the number of moles? Already they have given the volume, how much it is, 28.375 volume they have given. So that is the given volume, and molar volume, how much we have got it, this is molar volume. So number of moles equal to, here what it is, given volume, it is given volume divided by molar volume, right? Given volume. If it is at what is it, solid substance, it is given mass by molar mass. So here given volume by molar volume. Molar volume, this is actually volume of oxygen. Here molar volume. Right now here, can we apply the given volume? It is 28.375 divided by molar volume. How much? It is 11.2. So you will get how much? It is 2.53 moles. Right. Now number of moles we have identified. So now here in this point, given mass we have to identify. So given mass of the solute. That is what, starting only I just mentioned, we have to identify that mass of the solute. Mass of this what it is, solution we found it. Now mass of the solute we have to identify. Okay. Now here what it is, moles into molar mass. Molar mass of what? Particular substance, that is here in this question, H2O2. So formulas really helps us to go for our destiny, right? Now here moles, how much you got it? 2.53 moles into molar mass of H2O2. Here 2 plus, here how much? 32. So here 34 gram per mole. Oxygen 32, no, and here to 34 gram per mole. So you will get altogether 86.1 gram. So given mass of the solute, it is 86.1. I hope you got that idea. Now come on, let us identify the mass of the solvent. Mass of the solvent. I just mentioned starting only, here you see, already I just mentioned this concept. Mass of the solvent equal to mass of the solution minus mass of the solute. Mass of the solute, just now we found how much it is, 86.1. Mass of the solution, how much we found, it is actually 1250, 1250. How much we got it from this density of the solution. I hope you remember this. Yes. Okay. Now let us go for that idea. So 1250 gram minus here 86.1 gram. So this is mass of the solution minus mass of the solute. So we will get the mass of the solvent. So what is the answer? Finally, you are getting how much? Here you will get 1163.9 gram. You are getting mass of the solvent. Now we are going to identify the molality, right? Molality equal to what it is? Molality equal to what it is? Moles per, or what it is? Mass of the solvent in kg. Moles per mass of the solvent in kg. So how much moles, how much just now you found, that is 2.53 moles divided by mass of the solvent. This is mass of the solvent, 1163.9 gram. So this is actually, here we have to convert into kilogram, right? So kilogram means what it is, gram converted to kilogram, 1.1639 kilogram, right? I hope you got that idea. Okay, we just converted into kilogram. So here actually 1.1639 kilogram, right? I hope you got that idea why I have changed, because here mass of the solvent in kg, so I just converted into kg. So what is the answer you will be getting when you calculate it? 2.17 mole per kg. Mole per kg is what it is, molality unit. So molality unit is a small m. So here what is the answer you will bring? So the molality of hydrogen peroxide solution, molality of hydrogen peroxide solution, molality of hydrogen peroxide solution, how much it is actually? 2.17 small m. This is actually molality, mole per kg also we can say. Come on, let us check the option whether it is correct or not. Yes, molality of H2O2 solution is 2, molality of H2O2 solution is 5, molality of H2O2 solution is 2.15, none of this. Actually 2.15, which is nearer to that, so we can consider option C as the correct option. I hope you got the clarity how to identify. So option C is the correct option. Come on, let's go to the next question. See, what are the steps? We just bring it, just go through once again so that you will get that full clarity. See, these questions and all important questions as well as little lengthier question to understand. It's not so easy. Just you have to go through 2-3 concepts to understand. That is what I just bring lengthier video. Right? Come on, let us go to the next question. Next question. The impure 6 gram of sodium chloride is dissolved in water and then treated with excess of silver nitrate solution. The mass of precipitate of silver chloride is found to be 14 gram. The mass, that is a purity, percentage purity of sodium chloride solution would be. See, generally percentage purity, you know what is that formula? So percentage purity, it is mass of pure substance divided by mass of impure substance into 100. Okay, I just mentioned the formula and the concept, then we can go for to solve this question. Right now, mass of purity, that is percentage purity equal to mass of the substance, mass of pure substance divided by mass of the impure substance, mass of impure substance, that is given, right? So NaCl means here what they have given, okay, into 100. Usually percentage comes means 100, it will be along with that, right? I hope you got that idea. So this is the formula we will be using. Now here mass of the pure substance we have to identify. So mass of the pure substance means given mass we have to identify. So given mass 14 gram they mentioned, then molecular mass. So in that way, but here they have given impure 6 gram of sodium chloride is dissolved in water and treated with the excess of silver nitrate. So that means a reaction takes place. From that we have to identify the number of moles. Then we can identify what it is, given mass of the substance. Then we can go for that final stage only, this percentage purity. Okay, come on, let us go and identify. So here sodium chloride, right? So here sodium chloride, here sodium chloride treated with what it is, silver nitrate, AgNO3. So you will get what it is, AgCl plus NaNO3. Is it balanced? Yes, it's bond balanced. We can say that way, that word, right? Okay, so moles ratio, it is 1:1. 1 mole of sodium chloride reacts with 1 mole of silver nitrate. It gives silver chloride plus sodium nitrate. Right now, displacement reaction. Here we have to identify the moles of AgCl. Okay, so moles of AgCl, we have to bring the point of given mass by molecular mass. So given mass, what it is here in the question, it has given what it is here. The silver chloride is found to be 14 grams. So given mass, it is 14 gram. Molecular mass of silver chloride 143. Right now here number of moles we have to identify. So number of moles of silver chloride. Why do we go for number of moles of silver chloride? Because in the question they have mentioned what it is. Silver nitrate solution, the mass of precipitate silver chloride is found to be that 14 grams. So here this is only found as a PPT. So this is how much it is, 14 gram. So this is given mass, it is 14 gram. Molecular mass, it is actually what it is, 143 point, 1.3 actually gram per mole. Right, sometimes they will provide in the question only all this molar mass and all. Okay, so nothing to worry. Right, now here, so given mass by molecular mass, it is number of moles. So let us apply that. So this is given mass by molar mass. So it is 14 gram divided by 143.3 gram per mole. So you will get what it is, gram will be cancelled. So you will get around 0.0977. 77 what it is, moles. Yes, got it. So number of moles we found it. Now we have to another next step, what it is, moles we have identified. Now we have to identify mass of that substance. What is it, mass of the substance? Given mass of the substance of NaCl. Why? Because here NaCl only reacted, the impure 6 gram of NaCl reacted with water and then treated with excess of silver nitrate solution. So the mass of precipitate of silver chloride. So silver chloride they mentioned and sodium chloride here 6 gram they mentioned. So now we have to identify the mass of that, what it is, pure mass of NaCl we have to identify. Right, now for that we have to go for what it is, mass of pure NaCl. Yes, mass of pure NaCl. So mass of pure NaCl, what it is? So how to identify this is actually moles into molar mass. So moles into molar mass, which mole we can take it? So we can take this mole only. Why? Because each one having what it is, 1:1 ratio. See, this is actually sodium chloride also 1 mole and even silver chloride also 1 mole. So actually this is equivalent to that. So that is the way here this mole, what is the number of moles of AgCl is equal to number of moles of NaCl. I hope you got that idea. So number of moles of AgCl, number of moles of AgCl is equal to number of moles of NaCl. I hope you got that idea. Why we are not taken here 6 gram? Because it is impure substance. We want a pure substance, mass of pure substance. That is what we are going, because we here we got what it is, precipitate. It is a pure substance, what we got it. So from there that moles into molar mass of sodium chloride. So what is the molar mass of sodium chloride? Sodium chloride, it is 58 point chloride, what it is, 5. 58.5, right? Yes. Right, now gram per mole, it's gram per mole. Right, now here in this way, so here 0.0977 into 58.5 gram per mole. So this also mole, so mole. So here what it is, mole will be cancelled. This is actually gram per mole, so divided by, so mole will be cancelled. So which is remaining, gram only remaining. Why? Because we are calculating mass of pure substance, right? So that means, can we apply the value here? I mean, can we get the answer? What is the answer here you're getting? 5.71 gram mass of the pure NaCl, we got it. Of course, it is around what it is here in that they have given in the question 6 gram. It is more or less bringing that nearer to 5.71 gram. Right, now here mass purity, what it is, percentage purity. So percentage purity is what it is, percentage purity, just now I just mentioned that formula, mass of the pure substance divided by mass of impure substance divided by 100. Mass of pure substance, just now we found what it is, mass of pure substance this, and what it is, next one what it is, mass of impure substance, that is 6 gram. In the question only they mentioned, right, into 100. Yes, okay. So 5.71 divided by 6 into 100. So how much you will be getting? 95.147. Actually, it is actually 714 percentage. Right. So now, actually, what is it exactly? 95 percentage. Exactly, it is 95 percentage purity of that substance. So I hope you got that clarity. See, generally here, this kind of questions actually, it's very interesting. purity, percentage purity. First and foremost, you please remember whenever you are reading that question, please remember the concept. So concept you just apply, is it possible? Then you can go for another step. See, now this is that, as we mentioned that end of the point, it is percentage purity. So we are remembering this concept of mass, what it is, percentage purity equal to mass of the pure substance divided by mass of impure substance into 100. And the second point, we have to check the equation. For that, we have to identify the number of moles. The number of moles, next step, what it is, given mass we have to identify. That is mass of the substance we have to identify. So mass of the pure substance, how to identify? That is through moles into molar mass. So these are the steps. You please remember. Come on, let us go to the next question. Now, which is the correct option? Yes, option A is the correct option, 95%. I hope you got the clear idea about this question. Come on, let us go to the next question. Next question, Al2SO4 thrice solution of 1 molar concentration is present in 1 liter solution of density 2.684 gram per cc. How many moles of BaSO4 would be precipitated on adding excess of BaCl2 in it? Now we have to identify number of moles of BaSO4 would be precipitated on adding excess of BaCl2. Right, come on, let us identify that. Now, first and foremost, they have given the value in density. So, density equal to what it is? Density equal to mass by volume. Right. Density of the solution. Density of the solution. Solution equal to how much they have provided? So, here 2.684 gram per cc. Right. Now, that is centimeter cube also you can mention. Right. Now, next one, volume of the solution. So, here volume of the solution also they have provided. So how much they have provided the volume of the solution? That is actually 1 liter, right? Generally, volume of the solution easily we can identify, that is 1 liter, right? Volume of the solution. Volume of the solution, right? It is 1 liter, it is 1000 ml. Right. Now, here mass of the solution, because here mass equal to density into volume, so that is mass, right? So mass of the solution, it is easy to identify. Okay, mass of the solution, mass of the solution equal to density into volume. So density how much? It is actually 2.684 gram per cc into volume 1000 ml, right? Ml and centimeter cube, both are actually same only. It is not confusion way, both are same only. Okay, now here gram, mass of the solution. I think now you got that idea. So here 2684 gram mass of the solution, you got it. Now number of moles to identify. So number of moles of aluminum sulfate, number of moles of aluminum sulfate, Al2SO4 thrice. So Al2SO4 thrice, that is, you just imagine this is a x gram. Right now, molar mass how much? Molar mass of Al2SO4, molar mass of Al2SO4 thrice, that is equal to how much? You know, that is 342 gram per mole. Right. Now, mass of solute. How much mass of solute in the question what they have provided? So, it's actually mass of the solute they did not provide. So, we have to identify that. So, mass of the solute, how to identify? Here, mass of the solute. Mass of the solute. So, mass of the solute Al2SO4 thrice. That is equal to actually moles into molar mass. Actually, I just mentioned here grams. Actually, it is a mole, right? Sorry, this is mole. That is number of moles equal to. So here, can we apply the value here? X mole into molar mass, how much? 342 gram per mole. So mole and mole will be cancelled. So what is the answer you will be getting? 342 x. This mole and mole will be cancelled. This mole and mole will be cancelled. So 342 into x. So that is the mass of the solute. I hope you got that idea. Now we have to identify mass of the solvent, because mass of the solution we have identified. So this is mass of the solution. Mass of the solute. This is mass of the solute. Now we have to identify mass of the solvent. Mass of the solvent. Mass of the solvent, how to identify mass of the solvent? Mass of the solution minus mass of the solute, we will get that mass of the solvent. Okay, so here mass of the solution minus mass of the solute. So we will get what it is, mass of the solvent. Can we apply the value here? So what is that value? 2684 gram minus 342 x gram. Right, this is gram. I just mentioned this. Now here we have to identify the molality, because mass of the solvent, mass of the solution, mass of the solute. Now we have to identify molality. So molality equal to number of moles of solute divided by mass of solvent in kg, right? Mass of solvent in kg. Right, now here they have given a complex, right? So how to solve? So number of moles, we just mentioned it is a x. Here the first point, here x, no, so x divided by this point, okay, and divided by 1000 kg. Right, now here I just mentioned here x, number of moles divided by 2684 minus 342 x gram divided by 1000 gram. So how to solve this? So this is actually complex, right? So we just bring it over there. This is 1000 x equal to 2684 minus 342 x. Got it? Right, now here how to go for it? So here 1000 x equal to 1000 x minus 3000. Here when we bring it this side plus, right? 1000 x plus, we just bring this 342 x equal to 2684, right? So here how much you will get? 1342 x equal to 2684. So that means x equal to, I hope you got that idea. Simple it is actually. X equal to here 2684 divided by here 1342. So you will get actually 2. This is 2 moles. X it is mole only, right? So X it is mole now. So that is, there are 2 moles in that Al2SO4 thrice in 1 liter of the solution. Right, now here what is the 2 moles now? Just I wanted to bring that question. Here how many moles of BaSO4 would be precipitated on adding excess of BaCl2? So here actually 2 moles actually required. How many moles of BaSO4 would be precipitated on adding excess of BaCl2 in it? So here actually 2 moles according to this data. It's very simple. I hope you understand these explanations. So here how much you are getting? Here 2 moles you are getting. Yes, come on, let's go to the next question. Now which is the correct option? Option A, it is 2, right? 2 is the correct option, and it's very simple also, but looks somewhat going around the neck, but the questions are really amazing. The next question, a certain public water supply contains 0.10 ppb, that is parts per billion. You know what is the value of parts per billion? 10 to the power of here 10 to the power of 9. It's a parts per billion of chloroform. How many molecules of chloroform would be obtained in 0.478 ml drop of this water? You know, 1 drop, that is equal to 1 ml in that burette. No, when we go for practical lab, we will use that volumetric analysis in that burette, 1 by 1, drop by drop, we will add into that conical flask, right? So 1 ml, that is equal to 1 drop, right? Okay, now come on, let us identify here 0.478, that means half of that drop, right? More or less, right? Okay, come on, let us identify what is that answer for it. Actually here how many molecules they are mentioning now. So how many molecules, in the sense here Avogadro number will be involved. So that's what they mentioned, Avogadro number. Come on, let us identify the answer. So here density assumed D equal to 1 gram per ml they mentioned. Okay, now here 0.10 ppb, right, parts per billion. So density of water, generally it is 1 gram per ml they mentioned, right? Okay, now 1 gram per ml, so mass of water, so density equal to D equal to m by v, and m equal to D into v, density into volume. So mass of water, that's what I just mentioned, m equal to mass of mass of water equal to density 1 gram per ml into volume, it is actually 0.478 ml. So right now here, what is the answer you will be getting? Here you will be getting this ml and ml will be cancelled. So you will get what it is, 0.478 gram you will be getting. But here parts per billion they mentioned, So parts per billion actually what it is, yeah, parts per billion. So the mass of chloroform we have to identify. So mass of chloroform. Mass of chloroform, it is parts per billion divided by 10 to the power of 9 into mass of water. I hope you got that idea how to solve this, how to identify mass of water. Mass of water, just now we found this is mass of water, right? So here parts per billion, actually I just mentioned parts per billion, how much it is actually. The value it is 10 to the power of 9, right? So parts per billion, because always wordings will help you to identify, understand it, right? So this is here 0.1, no, they mentioned in the question 0.1 ppb, right? So 0.10 divided by 10 to the power of 9 into mass of water, how much? 0.478 gram. Right now, what is the value we'll be getting? Mass of chloroform is equal to 4.78 into 10 to the power of 11 minus 11 gram, right? I hope you got that idea. So mass of water you found, mass of chloroform also you found. Now we have to find out that mass of moles of chloroform. Moles of chloroform, how to identify? Given mass by molecular mass. So CHCl3, molar mass. Molar mass equal to how much it is? 119.38 gram per mole. This is chloroform. And now number of moles. So number of moles equal to given mass by molar mass. So given mass, how much? This is the mass of chloroform, right? So that is 4.78 into 10 to the power of minus 11 gram divided by molar mass 119.38 gram per mole. Right now, this gram and gram will be cancelled. So number of moles, how much? 4.004 into 10 to the power of minus 13 mole. Right. So number of moles of chloroform. CHCl3, because given mass by molecular mass, it is chloroform only I just mentioned. Right now here, yes. Okay, so number of moles also we found. Now, what is it? Number of molecules. So number of moles, next step, it is number of molecules. So number of molecules, what it is, already I just mentioned, Avogadro number involved. So that is Na, Avogadro number, right? So number of molecules. See, number of moles, it is given mass by molecular mass. Number of moles, it is actually moles into Avogadro number. Please note down whenever they are asking this kind of point, please note down this is the answer for you. So number of molecules, if they are asking, number of molecules equal to moles into Avogadro number. So moles, just now we found what it is. This is moles, right? This is moles of CHCl3, it's chloroform. So here 4.004 into 10 to the power of minus 3 into Avogadro number 6.023 into 10 to the power of 23. So what is the answer you will be getting? You will be getting around 2.41 into 10 to the power, this is 13, right? Sorry, this is 13, minus 13, right? So this is here 23, here 13. So you will get 11 minus 13 here plus 23. So you will get 11 molecules. Not moles, molecules. Right? I hope you got the clarity. See, you can bring this answer. Directly you can what it is, calculate and you can bring this answer, or you can bring like this way. Here what it is, 4.004 into 10 to the power of minus 13 Na. this also you can bring the answer. So according to the option, we have to identify. You can multiply and bring the answer, or you can bring such kind of this way. But Avogadro number, it has to be involved with the moles. Okay, so whenever you are going to find that how many molecules will be available, means please hold Na. What is it Na? Avogadro number. See, Na it has mentioned. So 4 into 10 to the power of minus 13. So 4.004 is. So 004 it is not considered. So 4.4 into 10 to the power of minus 13 Na. I hope you got the clarity. Yes, this is the correct option. Option A is the correct option. Yes, come on, let's go to the next question.